Good afternoon, everyone. Welcome to the conclusion of our first set of examples. The first set of examples on applications of sine rule. Please like, subscribe, and comment on these videos as we move forward together. All right, we stopped at question 6 the last time, so we will continue from question 7 now. Here, question 7 says. Here, question 7 says, a mast hangs from a horizontal beam by two strings as shown below. A mast hangs on a horizontal beam by two strings as shown below. So this is the horizontal beam, and this is the mast hanging on the beam. Let me change the color of the mast by two strings. This is the mast. Okay, 2.67438. So this is 2.6 meters, 74 degrees, 74 degrees, and what? And 38 degrees. So the question says we should use the data to calculate the length of the longest string in a triangle. What you should understand here is that this is a triangle. This forms a triangle. The longest string, this is a string, this is a string, this is a string. So the longest string is the string facing the bigger angle. So definitely this is the bigger angle between these two. And this will be the longer string facing it. Exactly. This string will be the longer one. This one here. This is the longer string. This string is the longer one. So we can use this diagram like this, or if we like, we could make another triangle from it that looks simpler, so that the beam will not be showing anymore. Okay. 74 degrees, 74 degrees, 38 degrees, 2.6 meters. We want to find the longest string here. Let's just call it L. So using sine rule, L over sine L. Let's call this angle L. Let's call this angle M, where the mass is, and call this angle N. So it will be element. So L over sine L is the same thing as N over sine N. So what does that give us? That gives us L over sine 74 degrees is what? N, which is 2.6 over sine 38 degrees. So all we just do is cross multiply. Can you see how I got N? This side facing angle N is side N. This will be M, although we don't need it. So side N is facing angle N. Side L is facing what? Angle L. So L over sine L is N over sine N. We cross multiply. This cross multiplication will give us L sine 38 is 2.6 sine 74 degrees. So L is 2.6 sine what? 74 degrees over sine 38 degrees. So put it together yourself. What do you get? The longest string will be your answer to this in meters. So you get your answer like that. That ends question 7. Let's go to question 8. It says, an aircraft is timetabled to travel from A to B. From A to B. Let's just assume that, A is here and B is here. So it's meant to travel from A to B like this. But it says, due to bad weather, it flies first from A to C and then from C to B. So it went first from A to C, and then it went first from A to C. So let me put directions so you can see. From A to C first. It traveled from A to C first, then went from C to B in order to avoid bad weather here. So the question says where AC and CB make angles 27 degrees with each other. Where AC and CB make angles 27 degrees with each other. I'm coming. I think I lost my page there. Okay. Where was AC and CB? This is AC and this is CB. They make angle 27 with each other. This is AC and this is CB. Both make angle 27 with each other. So that means this angle, we have been told this angle is 27 degrees. Okay, let's continue. There's more information in the question. Make angles 27 degrees with each other and 66 degrees respectively with AB, where AC and CB make angles 27 degrees and 66 degrees respectively with AB. Okay, I think I made a mistake. Okay, it means side AC makes angle 27 degrees with AB. So I'll put 27 degrees here. CB also makes angle 66 degrees with AB. So I'll put 66 degrees here. I think that's I'm sure. That's exactly what the statements mean. Side AC makes angle 27 degrees with what? AB. Side CB also makes angle 66 degrees with AB. So AC, let me explain that again, makes 27 degrees with AB and CB makes 66 degrees with AB. So it says where sides AC and CB make angles 27 degrees and 66 degrees with AB respectively. So that's where those angles will be. The question now says we should calculate AB if AC is 220 kilometers. AC is what? 220 kilometers. We should calculate AB. Let's just call this small letter C. Call this small letter B and this small letter A. We know how we do it. That will give us what? We want AB, which is represented by side C. The length of AB is represented by side C. So C over sine C, which is this angle here, is equal to what? B over sine B. This is B, this is angle B. This is side B, this is angle B. So that will give us what? C over sine. Okay, before we go forward, we need to find angle C. How do we do that? Angle C plus angle A plus angle B is 180 degrees. Okay, what's the reason for that? Your reason should be there to score sum of angles in a what? In a triangle. Sum of angles in a triangle. So that means angle C plus 27 plus 66 is 180. C plus what? 93 degrees is 180 degrees. So C is 180 degrees minus 93 degrees. What does that give you? Angle C is 87 degrees. So we can put 87 here as our angle for C. So I'll go back to my sine rule. C over sine C is what? B over sine B. So that gives us C over sine what? 87 is B, which is 220 kilometers, over sine what? 66 degrees. I hope I got that right. Yeah, 220 over sine 66. Okay, let's move forward. What do you do next? What do you do next? C times sine 66, you cross multiply. C times sine 66 will give you 220 times sine 87. Take note, this multiplication sign is not compulsory. You can skip it. So that gives you 220 times sine 87 degrees divided by sine what? 66 degrees. So you press your calculator, get the distance between A and B. So you write, therefore, the distance AB is so kilometers. You can leave your answer in 2 decimal places. Whatever you get here is what you copy here to. Use your calculator to complete that. Let's go straight to number 9. Question 9 says, 2 wires support an electricity pole as shown in figure 5.17. Okay. If the wires make angles 58 and 67 with the ground, AB is 21 meters and AB is 21 meters. Calculate the length of the wires. Okay. This is the electric pole. This is the electric pole. This is the electric pole. Okay, 58. Okay. 58. I think this is what? I'm not drawing that well. Hold on. 67. 58, 67. So, and AB is 21 meters. So this distance is 21 meters. Okay, I think those are wires supporting the pole. So the question says we should calculate the length of the wires. So let's represent, I think I should correct this. The pole actually goes up beyond the point of support. So let's extend the pole here. Okay. So let's call this place P. So we use that to find the length of the wires. The length of the wires will now be what? Length of wires. What are my wires? AP. AP and what? And BP. So the length of the wires will be AP and BP. Okay, that's okay. So what we need to do here is very simple. Just find this angle, this third angle remaining. We know 58, we know 67. Let's just find P. You understand? Assume this is a triangle P, A, B. Because this will be B here. From our question, this should be B. So, if you like, you can draw another triangle that will not have the pole or anything. Just draw triangle. Just draw triangle APB. What would that look like? 58, 67, 58, 67, P. So that's what? Let's find P. Angle A. Angle A plus angle B plus angle P is what? 180 degrees. So 58 plus 67 plus angle P is 180. Your reason must be in bracket here. Sorry, I forgot that. You can simply write angles in a triangle. Or you write sum of angles in a triangle. Both are okay. This is 125 plus P is 180. So P is 180 minus 125 degrees. What does that give you? That gives you what? P is 55 degrees. So you can label this place now. You can label this place now. 55 degrees. So they want the length of the wires. Let me use this as A. Let's use this as A and B. So this is 21 meters. It's been given in the question that this distance between A and B is 21 meters. So I can now say A over sine A is equal to B over sine B. So A over sine. Okay. I'm going to need to use P because we have more than one unknown here. So I can't use this set. Let's just take it one by one. Let's find A first. A over sine A is P over what? Sine P. So that will give us A over sine 57 is what? P. What's P? 21 meters over what? Sine 55 degrees. You cross multiply. This is how we got our P. This is angle P. And the side facing P is what? Side small letter P. So P over sine P is equal to A over sine A. So in that set, the only unknown will be side A. You cross multiply, say A sine 55 is equal to 21 sine 57. So your A is 21 sine 57 over sine 55. That gives you your A. And your A is the length of BP. So BP is equal to, you leave your answer in 2 decimal places. Okay. Also, the same way, you can do B over sine B. You can also do B over sine B is equal to P over sine P. What will that give you? That will give you B over sine 68 degrees is 21 meters over sine 55. So when you cross multiply, B sine 55 gives you 21 sine 68 degrees. So to get your B is 21 sine 68, not 58. 21 sine 68 over sine 55 degrees. So that gives you your answer. So whatever you get for this value of B, you can write it in 2 decimals, and the length of B is the same as the length of the rope AP or the wire AP. You leave your answer in 2 decimals with a space. Let's answer the last question in the exercise, question 10. Okay, how do we answer? Question 10 says, from point A and B on level ground, angles of elevation of the top of a building is 25 and 37, respectively. AB is 57 meters. Calculate to the nearest meter the distances of the top of the building from A and B if they are both on the same side of the building. Okay, let's just draw a line to represent. Okay, let's just draw this to represent the building. Okay, from point A, the angle of elevation of the top of the building is, angle of elevation means how much you have to look up. Let's say this is point A and your eyes are here. Let's say this is your eye here. The level of your eye is here. How much do you have to look up? You have to look up by 25 degrees. to see the top of the building. That's what this means. 25 degrees. That's elevation. Okay. Next, let me clean this and write it inside. 25 degrees. Next, it says another point B here. Let's put B here. From another point B, the angle of elevation of the top of the building, make this a straight line, is what? 37 degrees. See, I'm making it, I'm putting B here because I know that since 37 degrees is bigger than 25 degrees, it means that at point B, you have to be closer to the building. You understand? For you to, need such a big angle of elevation to see the building. The closer to the building you get, the more you have to raise your eyes up before you can see the top of the building. That's what tells us that an angle of elevation 25. That's what tells us that angle of elevation 25 will be much farther from the building. Will be much farther from the building than an angle of elevation. An angle of elevation which is 25 is much farther from the building than an angle of elevation which is 37. Now, if we have another point, let's say we have another point C, which requires an angle of elevation maybe 75 degrees. C will be put in a place like this. Because for you to need to look up more, it means you are getting closer to the building. So don't let that confuse you. That's what tells us which one to put far away and which one to put closer to the building. Once you see the angles of elevation, the closer one is the bigger angle of elevation. The point with the bigger angle of elevation should be placed closer to the building, because at that point you will need to look up more before you can see the top of the building, while the point with the smaller angle of elevation should be placed farther from the building, because you won't need to look up that much. If there's another point now where the angle of elevation is maybe just 15 degrees, that point will be somewhere here. That point will be somewhere far away here. The angle of elevation will just be very small when you get there. So take note of that. It now says that AB, the distance between A and B, is 57. So the question says we should find the distances of the top of the building from A and B. Okay, that means what we need is these two distances. We need this, let's call it X, and we need this, let's call it Y. So I'm going to call this T, top of the building T. So this tells me I can take out this triangle if I like. This is a triangle, 1, 2, 3. I can take out this triangle if I like. Let me draw it so you can see it. I can take that triangle out. How do I do that? Very simple. Let me figure out all of its angles first. If this is 37 and this is a straight line, this will be 180 minus 37, which is what? 143 degrees. Can you see that? Let me explain that again. At point B, this is a straight line, and point B is here. There's a line there, 37. The remaining angle here should be 180 minus 37, which is 143. So that's not confusing at all. That tells us that the angle here, is 143. Also, I know three angles of triangle TAB now. I know two angles of triangle TAB now. I know the angle at A here. I know this obtuse angle at B, but I don't know this one. So I can use sum of angles in a triangle to get it. Can you see? I can say angle at T plus angle at A plus what? Plus angle at B is 180. Sum of angles in a triangle. I'll cover it. So I don't know angle T, but I know the angle at A to be 25 degrees. I know that at B to be 143 degrees is 180 degrees. So T plus what? 168 degrees is 180 degrees. So the angle at T should be 180 minus 168. The angle at T is 12 degrees. So this tiny angle here, that tells you that this tiny angle here is what? 12 degrees. So I can take out triangle TAB now. Look at my pink lines. I can take this out now. If I like triangle TAB, I can take it out now. So I know what I'm dealing with. Is that clear? So that I can use that to find X and Y. Let's go. So, removing triangle TAB, what do I get? Let me use this. $57 degrees, 25 degrees, 143 degrees, T, 12 degrees. So, I think I have everything I need to get X and Y. Y, X. Am I keeping to the labels correct? Okay, so let's use sine rule. We can use sine rule. Okay, let's not confuse ourselves. Since I have letters for each angle, let's just use the letters. Let's just keep to the letters. So I'll call this place small letter B, this place small letter A, this is small letter T. So that our sine rule will not be ambiguous. So I can say A over sine A is equal to what? T over what? Sine T. This is 57 meters, not 57 degrees. A over sine A is T over sine T. Now, A over sine 25 degrees is T, which is 57 meters, over sine what? Sine T, which is 12 degrees. I hope you can see where I'm getting my angles. This is small letter T here, and this is angle T here. This is small letter A here, this side. This is angle A, 25. This will also be small letter B here, and this is angle B. You know, the sides opposite each angle is given the small letter name of that angle. What will this give us? Cross multiply, what do you get? A sine 12 degrees is 57 sine 25 degrees. So A is 57 times sine 25 degrees over sine 12 degrees. So what does that give you? That will give you the distance of B. That will give you the distance of B. That will give you the distance of B from the top of the building in meters. Okay, let's go do the next one. B over sine B is equal to, B over sine B is also equal to T over sine T. What does that give you? Okay, B is small letter B, but angle B is 143 degrees. So B over sine 143 is T, which is 57 meters. I don't need the meters there. I can take it out, over sine T, which is 12 degrees. Is that clear? So you cross multiply it to B sine 12 degrees is 57 sine 143 degrees. Now here, what does this give you here? This gives you B is equal to what? This gives you B is equal to 57 57 sine 143 divided by sine 12. So this side B, you get your answer in decimals. B is equal to 10. Side B is the distance from A to the top of the building. You write your answer in meters. You can leave it to 2 decimal places. That ends our first set of examples on the applications of sine rule. We'll be taking more in future in our next videos.